So thank you, Elizabeth, for the introduction. I think that I will do this great job of giving us a lot of time for you to ask questions to the speakers. The speakers also have done a very great job at highlighting the challenges of analyzing the importance of the health effect of environmental exposure. And so you will see in this discussion that I basically will just repeat some of the key challenges that they have already examined. So in organizing this discussion, I decided to first start with what are the challenges that we encounter from a statistical point of view when we're trying to understand what is the health impact of exposure to physical environment, where here physical environment means temperature and pollution, in the present or in the historical data. And then the problem becomes even more complicated when we're trying to project to the future. So Howard has already talked about the fact that when we work with health data, we already have some problems with the fact that the data that we usually work with is observational data. And so when you took a statistics class, you learned that if you're trying to understand the association between a covariate and your outcome, you have to be particularly careful when you have observational data because you have to account for confounding factors. And so Howard talked about the confounding factors when we're looking at data in a time series framework. Nowadays, we often have data that is over space. And so we need to think about how to characterize confounding factors in the areas at the area level or at the community level. And so this is another challenge because sometimes we don't have much information at a very fine temporal scale for some of the characteristics of the communities. So if you think about census data is available only every 10 years, or if you think about green space or vegetation or other characteristics, they are not maybe available at the spatial scale that you have health data. And Christy Ibai, in the first day, she also mentioned the fact that if you work with infectious disease data, in some cases you have presence-only data. And so the statistical models that we develop for health data, they have to take into account the characteristic of the health outcomes. And then some other key challenges that I mentioned here, I'm not talking about all the possible challenges that we have in this type of studies. I'm just highlighting some that came up in the talk and that to me are more important, but there are many others. So one question that is very important is what is the time window of exposure? So Howard showed you some studies where he was looking at short-term exposure and he was looking at exposure the day off and the day before, but really sometimes when we do these health studies, we don't know how far we need to go back in time. Is it 2 days? Is it 3 days, 4 days? Sometimes environmental health scientists try different combinations of lag exposure, or they use what are called distributed lag models, where you try to model parametrically what is the form of the effect of the exposure over time of a short time window on health. What is also has been shown is that if we just use the exposure the day of, sometimes we have a biased estimation of what is the effect of exposure on health. And so it's important to account for the exposure the day before, 2 days before, maybe even 2 weeks before. It is also important that when we come up with this window, the time window of exposure, that we talk with specialists. So Monty in her talk was looking at a particular time window because she had information about when is that the fetus develop the palate. And so there are some biological information that can be useful in determining the time windows of exposure. But in general, we want to come up with models that allow you to identify what is the critical time window of exposure. Another challenge that is very important, in particular if you're interested in understanding or designing intervention, is understanding what is the difference in the vulnerability in the population. So exposure does not affect everybody in the same way, and so there are groups of the population that might have an increased vulnerability to the effect of environmental exposure. And the way we can quantify this effect modification is by constructing interaction of environmental exposure with other factors. So we can construct interaction of exposure to pollution with other factors like socioeconomic conditions and things like that. Another challenge is this issue of measurement error and exposure misclassification. So we often characterize exposure using the ambient measurements, but there is a difference between ambient exposure and what is the true exposure in an individual experience. So if you think about studying the association between temperature and a health outcome, people don't spend all the time outdoors, and if you're looking at heat in particular, people that have access to air condition are probably not are not exposed to the same temperature as people that don't have the economic means to operate an air conditioned system. So there is work that needs to be done to understand what's the difference in terms of the health impact when we look at ambient exposure versus when we look at the true experience exposure. Howard talked a lot about methods to come up with better measure of exposure. And so he talked about how we can combine satellite measurements with computer model, land use information, and monitor data to come up with better estimates of exposure to air pollution. Oftentimes, what we see in the literature is that we have two separate models. We have a model that we develop for estimating exposure, and then we use that predicted exposure in a health model. There is actually a lot of debate about whether this is the best approach. Adam Spiro wrote a paper that was looking at ways to actually try to do this imputation as it should be done if you're using the missing data framework, where you should actually model jointly exposure and health, and he was proposing a bootstrap method to try to get an approximation of what will be the imputation if you were using a joint model, but you're breaking it down into two stages. And then Muncie mentioned this issue of multivariate exposure. We are really exposed to multiple pollutants. So then the question is the effects of the pollutant additive? Are the pollutants interacting between them? And when we're looking at temperature and air pollution, is the effect of temperature and air pollution a confounding effect, a modifying effect? So oftentimes when we look at studies of air pollution on health, people control for the effect of temperature, but it's not said that there is only a confounding effect of temperature, but there might be a modifying effect. So you can see that there are a lot of challenges when we're trying to look at what is the effect of environmental exposure on health. If you're looking at the present or historical data, you can think about if we're trying to project to the future, these problems get just even magnified. So I'm not very familiar with the health impact studies, so I'm glad that Jason went over some of the specifics of how health impact studies are done. In my mind, I think one of the major problems is this problem of extrapolation. We are using the health effect estimate that we have gathered from our historical data, and we are projecting, assuming that maybe the baseline mortality, risk of mortality is the same, or that there is the same relationship between pollution or temperature now as it will be in the future. Another problem is, I think that Jason addressed, is the spatial scale. So oftentimes we have this global climate model at a very large scale, and when we're looking at the health impact, we want to make conclusion at a very localized scale. And we need to be very, very careful about using indices that are derived by using statistical downscaling products of climate models. And then there is the issue that I think came up a lot on Monday about the quantification of the uncertainty in this projection. So the last set of slides is basically based on Monty's presentation. So Monty presented a very sophisticated statistical model to understand the effect of multiple pollutants on a multivariate health outcome. And she tried to address for several of the questions that I mentioned before: the critical window of exposure, multiple pollutants, using multiple data sources to get information on the exposure, and in some ways also the fact that individuals do not stand still in a location, but they move around. And so what she suggested is a very complex model that can be thought as a spatial dynamic version of what in environmental epidemiology is called a source apportion model, where what we're trying to do is we're trying to take a lot of pollutants and see if there is a common set of footprints that can tell, oh, these pollutants are driven mostly by traffic, these pollutants are driven mostly by coal combustion. And so we can try to reduce the dimensionality of the problem to a smaller set of factors. And this is very important, especially if you're interested in environmental exposure management and think about what would be the effect of reducing, for example, traffic in terms of health. However, on the negative side, sometimes interpretation of the factors is not easy. And also, this approach does not allow to account for possible interaction between the pollutants. So one thing that I hope that this working group does is actually work on this issue of multiple pollutant models. There is work that has been done in this area in the environmental epidemiology literature and in statistical literature, but most of the methods that have been proposed, variable selection or lasso and other deviation of lasso, are all non-spatial. And so it will be interesting to see how we can come up with models to address multiple pollutants in a spatial context. And then the other thing that it is not addressed much is, again, this interaction between exposure to temperature and multiple pollutants. So there are other areas of interest that I hear about a lot in the School of Public Health. And so I thought to bring them up here. And also I think Howard mentioned them in his presentation. So there is a lot of interest nowadays because there is a growing incidence of allergies and respiratory problems in children, to look at what is the effect of pollen on health. And pollen is not being studied a lot, so it will be very interesting to look at the temporal and spatial variability of pollen concentration and what is the effect of exposure to pollen on respiratory disease. And particularly, there is this idea that maybe there is differential vulnerability to pollen across subpopulation. And then another area that I think is talked a lot, and there is some connection with extremes, is wildfires. So what is the impact of wildfires on air quality, and what is the impact of wildfires on health and respiratory disease? And finally, the last slide is somewhat of a very selfish slide. So I think that there is a big group of statisticians and mathematicians and climate scientists in the audience. But I think that for this working group that is really focused on health, it would be great if we had a more varied audience, and we had people coming also from environmental epidemiology, from environmental health science, urban planners, environmental engineers that can give us that insights on what are important scientific questions that need to be addressed, what are particular aspects of exposure that are relevant that maybe us as statisticians alone cannot come up with. And then the last bullet is something that I thought as a result of, I think it was Lenny who said on Monday, science to inform versus science to advocate, or something like that. And so I was thinking about what type of statistics do I like to do? And then in my department, we've been talking a lot about thinking about coming up with a mission statement for you and for what you want to do in your career. And I think that what I would like, again, selfishly for this working group is to think about how to combine statistical innovation with statistics for impact. And that's all I have.
well. But is there a specific question for Monty? For Veronica, as Monty and Howard and Jason come up.
Thank you very much. Howard, I have a question for you. Very nice talk. I'm Chen from University of North Carolina, Charlotte. So I work in a very similar area like you. Like Atlanta, Charlotte is I think the largest city in North Carolina. Well, larger than Durham. And a lot of, the disparities and this heterogeneity, spatial temporal heterogeneity. So I'm currently working on a project of modeling how the socioeconomic and environmental impacts the vector-borne disease dynamics. And I just wonder if you can give some advice on, especially for these large city urban areas, how you deal with the fine-scale temporal, spatial, fine-scale variability of the temperature, like the climate data and the weather data, how you deal with that. For instance, I know in Charlotte, we only have a few weather stations, but we want to model the larger Mecklenburg or Charlotte area climate patterns. How do you deal with that? Do you use some kind of interpolation, extrapolation, these methods, or you have some other, maybe a practical or theoretical methods to overcome this challenge? Thank you.
I'll try, but I think there's some that everyone on the panel can chime in. So I'm most familiar with air pollution exposure, and for temperature, we have been working with just the airport monitor. We have trying to do some kriging with the cooperative network. There's also, if you want to use monitor, I know people have experience with the weather underground data. That's another source. If you have to kind of validate it a little bit more, but really what's in the literature, exposure assessment for temperatures it's limited, especially if you're interested in the urban heat island effect. So if your region is large enough, getting that urban-rural contrast. And there's no reason why we are just starting a collaboration with NCAR, looking at what they have done in the Houston area. Now, in terms of the SES, the only advice I can say is try to work with a social epidemiologist, because what we have learned is that depending on a scientific question, the spatial scale of the SES modification effect, or just the main effect, can be very different if you're looking at walkability, disparity, segregation. So there's a lot of kind of social science paradigms and theory that can really help drive at least kind of narrowing down the model building and the questions.
Richard?
When I tried to ask this question earlier, it was meant as a question for Howard, but I think I'm going to turn it into a question for all three speakers. So, Howard, at one point in your talk, you had a slide. You had a slide where I think it was headed "Emergency Room Visits in Atlanta," and if I was counting correctly, you displayed 48 confidence intervals on one slide, and 46 of them, 0 was an interior point of the confidence interval. And Montse, you had a very similar slide somewhere in your talk, and I'm afraid you didn't leave it on long enough for me to do the same count. But I think it might have been a similar sort of phenomenon. And I mean, this whole sort of effect of multiple testing on these estimates has been discussed a lot in the literature. I'd be interested to hear your comments about it. But I'm also going to turn this into a question for Jason as well, because Jason, what you were doing is taking estimates that come out of studies like Montse's and like Howard's and producing these global estimates. And do you have any concerns about the level of confidence in the results you're getting out as a result of those sort of statistical issues?
Yeah. What I had shown was this on?
I think it's
Okay.
on.
Okay. Well, thanks. We looked at health effects attributable to climate change from individual models, and we got quite a spread among the different models. And inevitably that would lead, regardless of how you handle the statistics at that point, you're going to end up with a big spread of results, including in my case, a range that span positive and negative values. And I think that reflects not just our uncertainty in the health effects, but more so our uncertainty in the effects. What's the effect of climate change on air quality in the first place? And how does that then overlay on population and give you health effects? So yeah, I'm concerned about that. I think that field has a ways to go to really, we have differences between models. Some of that is just a factor of the features of the different models and how well they represent atmospheric processes that in different places, but it's also missing processes in some models. So I think our result then really characterizes where the field is right now, which is that we've got more work to do.
What I would like to add to that is that I think that one of the reasons why we need to characterize the spatial temporal dependencies, bringing data together, is in these type of environmental health problems, in many cases, the signal is very weak and you can see it potentially is positive, but it's not significant. But what I have observed is that once you bring more information, if you bring the temporal information, then you can see the signal. But then, of course, when you bring the temporal information, you need to characterize the dependence across time too. So that's, I think that that's really the whole purpose of bringing more power, more data together, but at the same time, the issue is the different levels of dependence that you have in the data.
Merrily, I've got the microphone, so I get the next question. I snuck up on you, man. So this question's for Monsi. So this question is for Monsi, but generally speaking, for those who are sort of less statistical in the audience, in a very simple regression situation, we have something called errors and variables. And it means that when you're plotting y against x, both y and x are measured with error, both of them. Both the regressor and the regressee are measured with error. And what happens is that any estimate or inference based on errors and variables, if you don't recognize it, ends up with a biased result on the coefficients, on the regression coefficients, and on the predictions as well. Monsi, in your talk, I believe you have errors and variables. Certainly the pollutants that are measured have errors in them, and I think the health measurements also have errors in them. And I saw in your equation, I didn't see the errors and variables part of your equation, or to put it in a format that I mentioned on Tuesday, I didn't see a data model. I saw a combination of a process model and a data model together. And I would have liked to have seen the pollution effects taken out in a separate equation. In fact, I think you probably should have had 3 equations rather than 2. And that would allow you to predict the underlying science process, not the noisy version of the process, which is what I think your current formulation gets you.
There is an understanding of the measurement error in the pollution, so from different monitoring stations. So there is an error component in the observation equation. So for the pollution, there's an observation equation and the pollution equation. So the observation equation, where we have the data, what is being observed, that's all that we have. And then the factors, but there is the error component. And for that, we do have an information. Furthermore, is for the different stations, we have also an understanding of the different type of error. So that's part of that error component where we have that characterized that error component. When we go to the health model, what we are taking as predictor is the version of it without noise, in the sense we are bringing those factors. Those would be the predictors that we're using in the model. But an understanding and appreciation of the error, it is there with that error component in the observation equation.
Yes, and it's confounded, and because it's confounded, you cannot filter it out. But I would put to you, you should filter it out, and if you have a separate equation, you can filter it out.
Well, I mean, if you have an understanding, as you do in this case, of what the magnitude of the error, you can characterize that, right? Because that error component has very narrow priors with regard what the measurement error is, because there's an understanding of how the different stations work, right? So, you do have a separate equation because you have the pollution, that's the data, and then you really have the error component. I mean, it's true that you just bring the dimensional reduction there, and you could put a first stage and potentially second stage.
I think you should, because if you do, then it would be clear what your target is. But currently, your target is something with measurement error in it, and you also run the risk, I think, in those coefficients of their being biased because of that general idea of an errors and variables model, where you need to have the regression on the underlying process itself, on the process, not on the data. That's perhaps a modelling decision that we make, and we make it differently.
Yeah, thank you.
Yes, these are great points and speak to the need for the working group discussion. So I think next, Murali had a question.
Yeah, so this is related somewhat to both Richard's and Noel's points. And so this is originally sort of directed to Howard, but I guess it's just now a general discussion. To sort of further complicate matters, there's this issue where if you have an accounting for spatial dependence or temporal dependence, you can also, this is stuff that Brian, Rich, and I have both done in separate papers, is there's the issue that it can steal away some of the information from the regression coefficients in your regression model. And so, so there's that issue, and then there's also sort of the general ecological fallacy sort of problems that, this is an incredibly difficult problem. So all I'm sort of asking is, do you have thoughts on how one might go about addressing those two issues in addition to the kinds of issues that Richard and Noel were bringing up?
I'll start first. So you're correct that when we try to select a model, it's lots of input, and the effect of measurement error, whether it's attenuation or it might impact model selection for confounders. So at least in the environmental epi field, we've taken a conservative approach. That is, we are willing to actually sacrifice precision for bias. So we might push the model actually with a lot more confounding controls, even though we recognize that it might steal away some of the main effects of interest. But I think I cannot speak for the field, but the general philosophy is to play on the safe side. And even though we recognize there's going to be attenuation and stealing, but so that's a point well taken. There are some works, a lot of measurement correction work, especially in the spatial setting, is trying to kind of go back and to see how much attenuation you have to make the post correction. So some of the stuff that I think Veronica mentioned about looking at the discrepancy between ambient, what's actually outside versus a personal exposure based on commuting or time activity patterns. Again, you need those data only from a very small subset of the population, but you can come up with some potential correction factors that people are trying to build into the models. But in terms of ecological bias, I think we struggle with that all the time, and it's really defining what is your exposure and what is your outcome. From a regulatory point of view, looking at ambient level that's applied to the entire population, and looking at the total events counts within that population. It's kind of how we frame the question, because it depends on how you change the question. So for example, when I start stratifying within a region, the ecological bias and the measurement error are enhanced. And that's why there are all these efforts to try to do a better job in that sense.
Yeah, that's linked to the mobility issue, right? So a way to see that is sort of the same thing that I was talking about with the pregnant population, that how you characterize and at what time if they're moving throughout the pregnancy, and that's why you have information that you have is what happened at the end, but that's not really doesn't matter how you average that, you completely miss what the exposure was at a given time. So I think it's a combination of getting access to spatial information across the space, able to develop the models that can run the analysis at that high level of resolution.
So great, that does bring us right up on our time. I did see one other hand up over here, and this side of the room got ignored a little bit. But looks like David had one last question. He was quicker, so I'll take one last question.
I have a question for the session chair, Elizabeth, not the panelists, but it's inspired by the panelists. It's my understanding that in November, the EPA released a lot of data on sources of pollution, and I think also combined with fate and transport models that indicate where those particular pollutants wound up. We have from Monsi's group and others data on sensors, so we could perhaps try to validate the fate and transport models, and if they work pretty well, then it might even be possible to build a fate and transport model for the cocktail of all the pollutants that are out there. Is this something that would be useful for a SAMC program to try to undertake?
So yes, absolutely. So first, let me start by saying that the EPA can neither confirm nor deny the existence of climate. And, that said, yes, I believe that was probably released by the emissions group, which is a group in my division in the Office of Air Quality Planning and Standards at the EPA, and we are a policy office, and so we are very interested in the real-world applications of the methodologies that are developed here, places like here in SAMC workshops, et cetera, and the policy implications, which can be very different. It is very different considerations when you're talking about policy versus research. That being said, I've talked with a few people here, and there seems to be quite a bit of interest in the idea of sensor networks. So that is kind of, we think, the next phase, sort of the new frontier of how we consider air quality measurements. There's also water networks. I'm just in the Office of Air. In terms of mobile sensors, personalized sensors, things that are out there that are outside of our network, well, though we don't have any control over them, nor do we endorse nor not endorse any particular air measurement system outside of our network. But that is, as David mentioned, something that we are very interested in, something that would be very useful to us to have these assessments of how do we consider these different types of measurements, how do we consider their quality, how do we consider what information are we actually getting from them spatially and temporally, can we implement them in downscaling structures, can we associate them with health effects? That's the sort of the ultimate question, is if we have these much finer scale measurements coming out of these sensor networks, are we able to then link them to an associated health effect? So yes, absolutely, that would be useful. So thank you very much, everybody, and it looks like we have a lot of exciting and interesting discussions for our possible working group on climate and health, and I think we'll talk about those tomorrow afternoon, if I'm not mistaken. So I have no information whatsoever about buses, but does anybody? All right, then. There you go. Thanks, everyone.